Assalamualaikum all of you. Welcome to one more session for the data transmission. Now today we are going to discuss about the data packets. What are the data packets? So for the data packets we are going to discuss that data packet is actually a small amount of the data that is also known as datagram. Usually it is of 64 KB bytes. Okay. Now when it comes to the datagram or the data packet, so it is quite easy to transmit the data from one end to another end if we are just dividing that particular data, a bulk amount of the data, into small chunks of 64 KIBs or more than that, or smaller than that. So it would be easier for us to transmit that. So when it comes to the packet structure, that means a small chunk, so there is a structure of that chunk. Now what is that chunk or how it is categorized further? So when it comes to the packet structure, so packet structure is usually divided into three categories. Number one, it is the header, then it's a payload, and then the third one is the trailer. Number one, header, payload, and a trailer. Now when it comes to the header, so what is the header? So header is something, it now includes four different things. What are those four different things? Number one is the IP of the source, from where you are going to transmit the data, from where the data is going to be transmitted, or from where you are going to transmit the data, that is known as the IP of the source. IP of the destination, where the data is going to be transmitted, from where to where, like from which location it is going to what location. So IP of the source, IP of the destination. Then we do have the sequence number of the packet. Now what do you mean the sequence number of the packet? Now let me show you with one diagram. Now if you can see this diagram, so these are the data packets over here. Now these data packets are actually divided. Okay, now the first one is the brown, then purple, then green, then blue, and then orange. When they are just transmitted, so they are transmitted from the various paths, that is known as the packet switching. We will be just learning about that thing as well. And when it reaches the other part, they are not synchronized, so they do need to synchronize with each other. So for the synchronization, what are we going to do? We do give them a sequence number. That sequence number is actually known as the hop number. And once they reach the destination, they resynchronize themselves, and that method of resynchronizing themselves is known as hopping. Hop, with the help of the hop number, they are doing the hopping. That means they are coming into the proper format once again. So that is also the part of the header. And finally the packet size, that how much of the KBs or MBs is the packet of. So there are four different things. Then come in the payload. Now payload do have an actual data, that what data is being transmitted. And then finally it comes with the trailer. Now trailer have two different things: method of identifying the end of the packet, and the other one is the form of the error checking. We discussed the error checking method in the previous video, that for echo check, ARQ check, sum check, direct parity check, parity block. We discussed about all six of them. So what type of the error checking method will be applied over this data that has been transmitted, and where the data is going to be ended up? So identification of the end of the packet is also there in the trailer. Now coming towards the types of the data transmission, so there are two different types of data transmission: circuit switching and a packet switching. Circuit switching you will be learning when it comes to your A2 levels or your A levels final year, and over here you will be learning with the packet switching. Now what is the packet switching? Packet switching is something that you are going to make the parts of like there is a bulk amount of the data, you are going to break it down into multiple datagrams or multiple packets, and now you are going to transmit them. Like you can see this diagram, so this data has been divided into multiple parts, and now once you are going to send it from router A and the destination is the router B, so each and every packet can take its individual path. So this is quite easy, because if any of the path, for example R2 till R5 is blocked, this one red one, so if it is blocked, so what are they going to do? They can just read out themselves and go to from R2 till R1. They will be taking that data, or they will be taking the routes that is quite suitable for that particular data packet, and when they will be reaching the destination, they won't be in a proper synchronized format. So for resynchronizing themselves, they do require a hop number so that they can resynchronize themselves to become a proper data. If you can see with the definition that I've written over here for the packet switching. So what I've mentioned over here, type of the data transmission in which message is broken down into multiple packets and each packet is provided a different hop number. Packets are then sent. There are nodes connecting to a different router as I just showed you, R2, R1, R5. Each node guides the packet towards the router from the shortest path available. Once they reach a destination packet, reassemble themselves using a hop number as I just told you. Now obviously there are few of the pros, few of the cons for the packet switching, or you may say there are few of the benefits or few of the drawbacks. So what are the benefits? Number one, no need for the dedicated channel. Now packet switching could be the example of a cellular network, or you may say a cell phone call. So you might see that when it comes to the towers, there are towers located over there. You can just utilize any of the tower, and that tower is not just for a single user. It can be utilized by thousands or hundreds of them at a multiple time or a single time, sorry. So you do not need a proper channel for this. You can utilize any of the channels, so there will be no wastage of the bandwidth as well. Bandwidth means that how much data can be transmitted at a particular time interval from a particular location. So no need for a dedicated channel. Possible to overcome failed, busy or faulty lines by simply rerouting them, as I just told you that if route 2 till route number 1, sorry, route 2 till route number 5 is busy, so it can reroute itself from route 2 till route number 1 and then go to the destination. Faster transmission obviously, and easy to expand the package usage. That means you can increase more packages, you can increase or you can transmit multiple data at the same time. But when it comes to the drawbacks, so what are the drawbacks? Packets can be easily lost because each of the packet is taking its own route, so it can be easily lost as well. More prone to the real-time streaming. That means not good for the real-time streaming, because if the packets are lost, you won't be getting the complete details. Delay at the destination, as packet needs to reassemble because the hopping methods need to be applied because they are not reaching in a proper synchronized manner. They need to resynchronize themselves at the destination. So this is something from packet switching. See you guys in the next session that will be regarding the network hardware. Thank you so much guys. Allah Hafiz.